Anabatic and katabatic winds are examples of local winds as they are restricted to a particular valley. They alternate between day and night and are characterized by a change in the location of pressure cells and the resultant change in the wind direction. The following basic information is important to remember in order to understand the development of anabatic and katabatic winds. Firstly, remember that there is a definite relationship between temperature and air pressure. The arrows, for example, indicate that when the temperature increases, the air pressure is going to decrease. So remember that temperature and air pressure always move in opposite directions. Wind always blows under the influence of a pressure gradient force, meaning that wind always moves from high to low. We name winds according to their origin or their starting point. For example, a southeasterly wind means that that wind has started or originated in the southeast. The following two terms are important in the development of these winds within the valley. Insolation means that this is the energy that reaches the Earth's atmosphere from the sun. It is an abbreviation for incoming solar radiation or energy that reaches the Earth's surface from the sun. The term terrestrial radiation refers to energy or heat that is lost by the Earth's surface. The word terrestrial means Earth, and in the case of terrestrial radiation, it specifically references the fact that the Earth is cooling off and it's putting all of that heat and energy back into the atmosphere. Remember the acronym DAVU, D-A-V-U, within the context of anabatic winds. D for day, which is when anabatic winds develop. A for anabatic, which is the name of this wind that develops during the day. V for valley, which is where the anabatic wind starts or originates. And U for upslope, which is the direction in which an anabatic wind blows. So anabatic winds develop during the day. They originate on the valley floor and they blow upslope. Let's have a look at the development of anabatic winds during the day. The sun sends out its energy, which reaches the top of the valley slope first at the beginning of the day. It means that the top of the slope is warmed and heated, and as a result of an increase in temperature, the air pressure at the top of the valley drops and a low pressure develops. As the valley floor takes a longer while to heat up, temperature is going to be lower, and this lower temperature results in the development of a high pressure on the valley floor. Under the influence of the pressure gradient force, the wind is thus going to blow from high on the valley floor up the slope to the top of the mountain where a low pressure is located. This resultant wind from high to low is called the anabatic wind. So in summary, insolation heats the top of the slope first at the beginning of the day, and low pressure develops. Valley floor is cooler, high pressure develops. The anabatic wind then blows from the valley floor, from the high pressure, up the slope to the low pressure at the top of the slope. If anabatic winds develop during the day, katabatic winds develop at night. If anabatic winds originate on the valley floor and blow upslope, katabatic winds develop up on the mountain top and they blow downslope. At nighttime, when the earth cools down by the process of terrestrial radiation, the air in contact with the Earth's surface also cools down, and that drop in temperature results in the development of a higher pressure at the top of the valley slope. The bottom of the valley or the valley floor holds onto its heat slightly longer, which means that the temperature is slightly warmer on the valley floor, developing in a lower pressure on the valley floor. The wind thus blows from the high at the top of the mountain downslope towards the valley floor at night, which results in the development of a katabatic wind. Katabatic winds bring very cold air and hence colder temperatures to the valley floor at night. Should the temperature on the valley floor drop to below 0 degrees Celsius, in other words, drop to below freezing, and there's any liquid water in the vicinity, that liquid water is going to freeze into a solid, and we often have the development of frost and frost pockets on the valley floor. The development of frost is a negative impact on agriculture and other human activities, and hence the valley floor that potentially gets extremely cold at night is to be avoided in terms of human settlement and also in terms of agriculture specifically. At night, katabatic winds will bring cold, dense, heavy air down the valley slope towards the warmer air on the valley floor. This cold, dense and heavy air reaching the valley floor will push itself under the warmer air. This cold, dense, heavy air reaching the valley floor will displace the warmer air. The warmer air that was previously on the valley floor is pushed higher up into the valley to create a valley inversion, and in this case we call the valley inversion a thermal belt, which is simply a layer of warm air inside of the valley where the temperature increases with an increase in altitude. The examiner is often interested in how the location of the thermal belt has an impact on human settlement and human activity within the valley. Please do ensure that you work through past question papers and memos in helping you to answer this type of question.